So in this experiment, we will apply the principles of subnetting in order to optimize the allocation of IP addresses in our network. Then DHCP server and even a DHCP server will be used to automatically allocate IP addresses from a pool of IP addresses which will be calculated using subnetting. Now, let us say we've got this network. So and the ISP has allotted this address to us 198.20.20.0 which basically has /24, which means 24 bits for the network. So there will be 4 subnets. That is, one is this here, then this, as well as this. So basically we divide the 256 addresses that we've got as by 4, and we get basically 64. So we will have 4 blocks, each comprising of 64 addresses, as we can see over here. Now the first network, that is network 1, we need 123. It requires 123 hosts. So now there will be 123 hosts plus network addresses plus broadcast just a single network and address and a single broadcast address, plus router plus server and switch. So this adds up to 128. So here we will be supernetting block 1 and block 2, which we have done over here, and we will keep 7 bits for the host because it basically we need to take one more bit for the network, so there will be 7 bits for the host. So your subnet mask will eventually be 255.255.255.128. Now network 2 needs only 48 hosts. This can be sufficed. These hosts will be sufficed, like along with the network address, broadcast address, router, server, and switch, which will add up to like 53 addresses required. Block 3 has already got 64 addresses, so it will be more than enough for network 2. But we will reserve 6 bits for our host. So we will basically take just 2 bits from the last octet for our network. We will just take 2 bits from there, and the subnet mask will now be 255.255.255.192. And now in network 3 we just got these 2 routers, so we will just have like network address, broadcast address plus these 2 routers, which is 4 IPs. So we basically have just block 4 left with us. So this we can very, very easily subnet into groups of 4 or into sets of 4 addresses. So that's what we've done here. In this case, only 2 bits will be there for the host, because basically you've got very less users. Earlier networks, why did we keep like 7 bits and 6 bits? Because we required that many users. Like you need at least 2 raised to 7 or 2 raised to 6 users, so to satisfy that. Now moving on to the DHCP server configuration. Basically what we need to do, first we have to specify our gateway. In this case, the gateway for this DHCP server will be this router, which has got an IP address of 198.20.20.1, and your DNS server will be 8.8.8.8. Then we go to services, DHCP. First we will give our default gateway and our DNS server. Here we will specify the start IP address. Now what happened over here is that in server 1 we have given 198.20.20.0, which will be kept reserved as our network address. 198.20.20.1.2 and .3 all got reserved by these 3 devices. So we basically just got 198.20.20.4, and then we keep the same subnet mask. So we will save, and then we do the same thing for the other router, by the way. But before all of this, we must configure the IP address of the server itself. So in the case of the server 1, we've got 198.20.20.3, which we intended to frame earlier. Remember, it becomes /25 because of the one, because we were using block. We were just using a combination of block 1 and block 2 here. So we had to take just one bit from the host part to the network. And we specify a subnet mask, which is 255.255.255.128. Then our default gateway, which is the IP of this router, and the DNS server. Now we will see whether this truly works. So I'll select a random PC4, which has no IP address defined. I go to DHCP. Now it is requesting for IP address, and the IP address should come in a while. It has. Then we also have like IP configs already given, like we've got 198.20.20.6. So we also have it for, I've already configured it for the other server as well. So we can just take a random one, check it there, check if that's happening there. So again, I've run this for one PC, and it's requested for, and it is successfully requested for an IP address, and it got allocated as well. So that's all in this experiment. Basically, we covered the principles of subnetting, as well as showed how we can configure and basically showed how DHCP servers actually help in allocating IP addresses, and how to configure these DHCP servers.